So for the next few sections, what we're going to be doing is looking at the parent graphs of trig functions, and then the following section we'll be talking about how to transform them. So it's going to be similar to graphs that we've already seen, but these have different shapes. So let's get started, and just like whenever we don't know any kind of graph, we usually make a table and we plot the points and we make a decision about what kind of shapes those are. So we'll do the same thing here. To get started, I have quadrantal and special triangle angles. Let's just fill this in. If you want, you could pause the video at any point, make the tables on your own, but in the interest of time, I already pre-made these notes, and there is a supplemental worksheet. You could find it in the link, but that has the completed notes. So I'm going to go through these from scratch. Start with the quadrantal angles. We know at 0 degrees, we have the point 1, 0. At 90, it's 0, 1. 180, it's negative 1, 0. And this point would be 0, negative 1. We know that the y value is the sine of that angle. X value is the cosine of that angle. And y over x is the tangent of that angle. When we have a 45, 45, 90 triangle, the smallest sides are always 1. The hypotenuse is root 2. Same thing with a 30, 60, 90. The smallest side is 1. The largest side is 2. And opposite the 60 is root 3. So now moving forward, I'm just going to fill in my chart here. Sine of 0, if you look at 0 degrees on your quadrantal angle, sine of 0 would be 0. Sine of 45 would be 1 over root 2. Which is 0.7. Now we'll use decimals for this table, but going forward, we always, of course, leave the rationalized form of that answer. Sine of 90 is the y value at 90, which is 1. Sine of 135, we could make our special triangles, but that would be 0.7. Sine of 180 is 0. Sine of 225 is negative 0.7. Sine of 270 is negative 1. This would be negative 0.7. 360 would be 0. And then 405 would be 0.7. And 450 would be 1. So that's the graph of sine from 0 to 450 degrees. When we go to take the reciprocal, that would give us the graph of cosecant. So if you do 1 over 0, that's going to be undefined. And actually, anytime sine is 0, cosecant would be undefined. When we do 1 over 0.7, the reciprocal of sine, that's going to come out as 1.4. So anytime we see 0.7, it's 1.4. Negative 0.7 would be negative 1.4. And the reciprocal of 1, of course, is 1. That's the first two graphs. Let's go to cosine. Cosine of, maybe I'll use green for this. Cosine of 0, if you look at your quadrantal angles, cosine's the x value, it's 1. Cosine of 45 would be 0.7. Cosine of 90 is 0. Cosine of 135 is negative 0.7. 180, cosine is negative 1. Then negative 0.7. 0. At 315, if you drew your special triangle and you figured out the cosine of that angle, it would be 0.7. Cosine of 360 is 1. Cosine of 405 is 0.7. And cosine of 450 would be 0. Now let's take the reciprocals and get secant. Just like before, the reciprocal of 0 would be undefined. Reciprocal of 1 is just 1. Reciprocal of 0.7 is 1.4. Now we'll move on to tangent. Tangent of 0, well, go to 0, look at the quadrantal angle. Tangent of 0 is the y over the x value, so 0 over 1, which is 0. Tangent of 45 is 1. And tangent of 90 would be the y over the x value is undefined. Tangent of 135 would be -1. Tangent of 180 is 0, 1, and then another undefined. And you can see a pattern start to emerge here. -1, 0, 1, undefined. As you'll see from the graphs, the trig functions repeat after a certain amount of time. That's called the period of these trig functions. Cotangent, we're going to take the reciprocal of tangent. So cotangent of 0 would be 1 over 0, or undefined. Notice that whenever tangent 0, cotangent would be undefined. The reciprocal of 1 is just 1. And then we have undefined for tangent, which was 1 over 0, so the reciprocal would be 0 over 1. So anytime we see tangents undefined, cotangent would be 0. So now we have our table complete. So let's go and plot these points and see what the graphs look like. First graph we'll do is sine of theta. Now sine of 0, remember we said that was 0. Sine of 45 was 0.7, then 1, 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, and you can start to see a pattern emerge. I'm going to connect these dots. And we can imagine what would happen if we were to continue this. That's what the graph of sine looks like. And you could see that this graph right here is going up, and then it does that again right here. So what we would say is sine has a period of 360 degrees. What the period means is that's how often it repeats. When's the next time it's 1 after 90 degrees? 360 degrees later. Now, when's the next time it's 0? Right here, but it's going up here and it's going down. So when's the next time it's 0 going up? 360 degrees. This graph also has a height. It's a wave. The height of the wave is called the amplitude. The way we measure the height of a wave is from the middle to the top or from the middle to the bottom. So the distance from the top to the middle, this is your amplitude, and clearly the amplitude is 1. Let's move down to graph y is equal to cosecant of theta. We're going to look at our chart and plot those points. So if sine was 0 at 0, the reciprocal would be undefined. I'm actually going to look at my sine graph, and anytime I see sine is 0, I'm going to draw an asymptote, which would mean that the graph is undefined at those values. When sine is 1, cosecant is going to be 1. And if you just start taking the reciprocal of our values for sine, you get a graph that looks like this. Now with 45 we had 1.4, 135 we had 1.4, and we start to see a shape that looks like this. Something like that. That's what our graph would look like. And you can see that this graph also repeats. You can see that we have an upwards parabola right here. This period would also be 360 degrees. There's no amplitude because it's not a wave, but it does repeat every 360 degrees. Let's go to cosine. Now cosine of 0 is 1, then it goes 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, 1, 0.7, 0, and we could kind of figure out what the pattern is. This looks very similar to our graph of sine. it's a wave, just like the graph of sine was. Cosecant was an alternating parabola kind of graph. And you could see that our period repeats every 360 degrees, and our amplitude from the top to the middle. Because it's a wave, it has an amplitude. The amplitude is 1. Let's graph secant. Now anytime cosine is 0, secant would be undefined. So that happens at 90 degrees. I'm just looking at the graph above. 270 degrees, 450 degrees, 90 degrees. Now cosine of 0 was 1, so the reciprocal is 1. 180 was negative 1. We have 1 at 360. All right, and we also had a similar numbers when we were graphing cosecant. We had 1.4s, negative 1.4s. I think you could assume what's going to happen. The graph of secant, also like the graph of cosecant, is alternating parabolas. Now the period for this graph is 360 degrees. There's no amplitude because it's not a wave. Let's move on to tangent. For the graph of tangent, tangent of 0 is 0, but then it looked like at 90 degrees it was undefined. I'm just going to draw my undefines first. That's going to help give some structure to the graph. So it looks like every 180 degrees it's going to be undefined. And then it goes 0, 1, undefined. Negative 1, 0, 1, undefined. And we could see that we do have a pattern. If we were to pick more points, the graph would look like this. It would actually look like cubic. This is what the graph of tangent looks like. Now it is a little bit different. It looks like we have a pattern that repeats more frequently than the other graphs. If you take a look from here to here, that's the period. And for tangent, the period would be 180 degrees. So it's half as long as the other graphs. Let's graph cotangent. Now anytime tangent was 0, cotangent would be undefined. So I'm going to look to see when tangent's 0, and I'll just draw an undefined there. Something like that. And if you remember with cotangent, let's go back to our table. The table for cotangent went 1, 0, negative 1, so it was almost like reverse. So 1, 0, negative 1. And if we connect these dots, it's also going to look like a cubic, but the cubic's going in the opposite direction. And you can see that this would have the same period as our graph for tangent. Period would be 180 degrees. So let's do a little summary of this. We'll discuss the function, we'll group them, we'll talk about their amplitude, their period, their shape, And it looked like sine and cosine were similar. Sine and cosine both had an amplitude of 1. Their period was 360 degrees. As we progress talking about graphs, we'll also be using radians. So 2 pi is the same radians as 360 degrees, and their shape was like a wave. Now let's talk about cosecant and secant. They don't have an amplitude because they're not a wave. Their period was also 360 degrees, or 2 pi, and their shape were alternating parabolas. And then finally, we had tangent and cotangent. They also had no amplitude. The only graphs with amplitude are sine and cosine waves. But their period was 180 degrees, or pi radians. And tangent looked like a normal cubic function. Cotangent was actually going the other way. So just make sure you're careful when you go to graph them. If you're ever not sure of how to graph one of these trig functions, you could always just make a table like we just did and then connect the dots. So to finish out our discussion about their parent graphs, I just wanted us to quickly graph the following. On the interval -2 pi to 2 pi. So we're going to be using radians here. So we'll just get practice going back and forth between degrees and radians. So first example, let's just do cosine. Now it's going to be a little unnatural at first for you because degrees come a little bit more naturally, but we've talked a lot about radians using the unit circle, so let's see how well you could do with this. Now at 0 radians, 90 degrees is pi over 2 radians, 180 is pi radians, 270, if you remember, was 3 pi over 2, and 360 degrees was 4 pi over 2. We could also label the negative points. And let's go ahead and graph this. Actually, what I'm going to do is I'm going to copy this graph so it's already made for the other two graphs that we're going to do later on. All right, that's 1 and 2. All right, so our graph of cosine, use a different color. If you look at your table, cosine of 0 was 1, cosine of 90, 0, and then we have this pattern going. We know that cosine was a wave, so you don't have to know every single point. We could just keep the pattern going. If you're not sure, make a table, convert to degrees, but the more you practice doing this, the easier it'll be for you to do that on your own. That's what cosine looks like. Our period is 360 degrees, or 2 pi radians, and our amplitude is 1. Let's go to our next graph. Let's go over what tangent looks like. So tangent of 0, if you remember, was 0. It repeated every 180 degrees. And then we also had asymptotes. Tangent of 90, if you remember, tangent of 90 is 1 over 0, so that's undefined. And if the period's 180, 180 degrees later, it'll be undefined. 180 degrees before, it'll be undefined. And before that, it'll be undefined. So tangent's going to look like this. Remember, tangent was a cubic. So we'll just continue our pattern. Our period for tangent is going to be 180 degrees or pi radians, and there's no amplitude. We'll do one more. Let's graph y is equal to the cosecant of theta. Cosecant, if you remember, is the reciprocal of sine. So the sine of 0 was 0. The reciprocal then would be 1 over 0 or undefined. Cosecant has a period of 360 degrees. So 360 degrees before and after, or 2 pi radians before and after. It will also be undefined. If you remember, sine of 90 was 1. The reciprocal would be 1. Sine of 180 degrees was undefined. And then sine of 270, the y value at 270 degrees is negative 1. So we could start to see a pattern forming here. And that's what we get. Cosecant looked like alternating parabolas, so we'll just draw those in. And that's some practice on graphing the parent functions of trigonometric functions. Stay tuned for our next section.